This is Electric Universe Geology, Earth News. You're looking at an image of Devil's Tower in Wyoming from Wikipedia. I have not been there. There's columnar basalt. There's a number of different theories. Standard geologists would say that it probably oozed up from below. On the outside, it cooled quickly, which made hexagons or column, not always hexagons, but columnar basalt, sometimes hexagons quite often. Although I've seen other articles where it said that the center of formations were columnar because they cooled slowly, not quickly. So it seems as if they need to play this in both directions, either slow or fast cooling creates these columns. And I've seen locations which imply that there might be another option for columnar basalt as opposed to a flow or something bubbling up from below. This is the area we're talking about. It's eastern Wyoming. Here's Devil's Tower down here. Here's Missouri Buttes West. And I'll have a link to Devil's Tower and Missouri Buttes West and photographs from Google Images. But this is a type of basalt up here that oozed up from below. And all of these flat mesas, I believe, are also basalt in addition to this. So I think that this material came down from above and coated these areas and was so hot that it made flat formations here and here. This might not have been quite as warm, enabling it to make something that's more stable and sticks up in the air as opposed to lies flat. That's just a guess. A lot of what I say are guesses. So none of this is in concrete. Anyway, we're going to look at an area in Oregon now with columnar basalt. So this is the area. It's the Cove Palisades State Park. According to the ranger who's spoken to many geologists, the basalt here flowed from the west. The basalt here flowed from the east to the west. So it came this way and went that way, all the way across the canyon. And then it was eroded afterwards. To the north of here, there's other areas where the basalt came from the west and flowed across the canyon to the east, and then the canyon had to be eroded. But it doesn't look like that when you get there and you analyze the size of the formations and especially the road cuts. So this is the road cut going down into the gorge. Up here there's been no removal. Here they removed the outside layer exposing columnar basalt. And here they removed the columnar basalt exposing dirt and rocks behind it. I have other images. Here's a similar angle. It shows that beneath the columnar basalt is dirt. It's not a question mark, there's dirt. So for me, the columnar basalt could not have flowed here. If it flowed here, there'd be basalt behind the basalt. It's a no-brainer. So this implies to me that molten red-hot dust flowed up the canyon, and where the water line was, it stuck to the side of the gorge, creating columnar basalt. So this would be a completely different model for creating columnar basalt. And it's not just columnar basalt that does this, but it's basalt flows that are not columnar, like in Taos, New Mexico. This formation is just south of Taos, the Rio Grande Gorge, and there's a road cut. And behind the basalt, where they removed the exterior layer of basalt, which is supposedly a flow, which crossed from one side of the river to the other. Supposedly, this is the west side, and the basalt flowed to the east side, and then the river created the gorge by eroding it. But if there's a flow, you're not going to have dirt behind the flow. This again implies to me that red-hot dust came up the canyon and stuck to layers just above the waterline. It would probably hug the waterline, being suspended in air, until it got spackled into something that was an obstacle, like the side of the gorge. You see this everywhere. It's a whole different way of looking at basalt. This gives a wider view of the area. Here's the Cove Palisades State Park. 26 comes up this way, goes through Madras, and then there's another gorge here with a road going through it. This is a massive one. Supposedly, this basalt flowed from west to east, and I got that from a number of different sources and visitor centers and geologists. Now, the cove, on the other hand, this basalt supposedly came from down here somewhere. There is a real volcano down here. What is it? This here. This is a real, honest to God volcano, although it does look kind of electrical there. So, the idea is that basalt flowing across here wouldn't have dirt behind it. It's the same thing up here. You see the same things. And by the way, the slow cooling basalt supposedly is the largest columns, usually hexagons, but sometimes different. The faster cooling basalt are smaller columns. But a lot of this basalt's on the outside, so it would be faster cooling. Faster cooling should mean not a lot of columns, unless it's an electrical process or somehow related to molten dust flying up and down the canyons. I would like a real honest-to-God geologist from any place on the planet to defend this. How can you have a basalt flow with dirt behind it? How can you have these areas that are classic basalt flow explanations without the goods to back it up? It's like they just pulled it out of their butt. Thank you.